This is a sequel video to Introduction to Complex Numbers Part 1. This is the second one, and I'm about to talk of multiplication and division of complex numbers, how to divide and how to multiply. The first video I discussed addition and subtraction, and I would want you to go over that video if you haven't seen it. If this is your first time visiting this channel, kindly subscribe to this channel and then go over my playlist Engineering Maths to Complex Numbers to watch this video. And let's box on to what we have today. The first thing I'll talk about is multiplying a complex number. So let's assume that we have the complex number Z1 giving us A1, IB1, where A1 is the real part of the complex number Z1, and then B1 is the imaginary part. We also have Z2 giving us A2, IB2, and we are told to find the product of Z1 and Z2. How do we do that? So to do that, we just multiply Z1 by Z2 and we will get the result. Let's do that. So we have the first bracket, which is A1 plus IB1 multiplying A2 plus IB2. So that is what we have. We will now use everything we have here to multiply whatever we have here. So we expand both brackets. We are having A1 times A2 is giving us A1 A2. Then we have A1 times IB2 is giving us plus A1 IB2. Then this time this is giving us plus A2 IB1, and this time this is giving us plus B1 B2 I squared. So we know that there is I here, there is I here. I times I will give us I squared, and then B1 B2. Now in the introduction video, which is the first part of the video, part 1, we studied that I squared is the same as -1. In the beginning we learned that I, which is the complex notation, is representing root of -1. So when we square here and we square here, we can say that I square will take care of the square root here, which is giving us -1. So wherever that we see I square, we can substitute -1. So then equation becomes A1 A2 plus A1 IB2 plus A2 IB1. Then when we substitute -1 here, we are getting the sign will change here to what? -B1 B2. Now all we need to do is to group all terms that are real, which is 1, 2, and we also have another term here that is real. We group all this term to one side, and then we can also group all terms that have the imaginary sign. All terms that do not have the imaginary notation is this side and this side, so we can group them together. So we have A1 A2 minus B1 B2. Now let me put it in bracket to separate them. And I'll factorize I here because it is common, the imaginary notation. So I am getting A1 B2 plus A2 B1 bracket close multiplying I. So therefore the product of Z1 Z2 is giving us A1 A2 minus B1 B2 plus A1 B2 plus A2 B1 times I. So this is our final result. You must know that when you have the value of A, B, and B, you can just subtract them, multiply, subtract them, and you input the values of A and B to complete the calculation. So this is how we manipulate multiplication of complex numbers. I will take only one example under this one, and then we'll move on to division. So we have two complex numbers here, Z1 and Z2. 3 plus 4i, 5 minus 6, where 3 and 5 are the real part, 4 and 6 are the imaginary part. We already know what I is. So we multiply them. Z1, Z2 is going to give us 3 plus 4i multiplying 5 minus 6i. So that is it. We can expand this. So we have 3 by 5 is giving us 15, and 3 times 6 is giving us minus 18i. There's I here, and then 4 times this is giving us plus 20i, and then 4 times this is giving us minus 24i squared. I squared equals -1. So we can substitute that. So we are having 15 minus 18i plus, you can choose to simplify this straightforward, 20i. And when we substitute this here, we are having plus 24. So we just have to add all reals and all imaginary. So we add this and this together, and we can add this and this together. So we have Z1, Z2 giving us 15 plus 24 is giving us 39. And then when we add this, we are getting plus 2i. So this is it. We end it here. This is the solution to the real part. So this is now the real part, and this is the imaginary part. So all you need to do is to remember that the square of I is -1, so that wherever you see it, you can substitute it there, and you will be able to complete the calculation. This is very simple. So now let's talk about division of complex numbers. So in division of complex numbers, there is something we call conjugating the complex part. So if we have two complex numbers, this and this, and we are dividing, we have a1 plus ib1, or dividing a2 plus ib2. Now the rule says that we have to conjugate the denominator, which is this, and we use the result to multiply the same function, whatever we have here, and we can complete the calculation. So what do we mean by conjugating the complex part? So the conjugation here means that whenever you have a complex number like this, you pick the denominator by changing the sign of the imaginary part. So if the sign of the, looking at this one, the sign of the imaginary part is positive, so we change it to a -1. So the conjugate of the denominator will give us a2 minus ib2, because the original form was a2 plus ib2. Now, so that means if I have a complex number as, let's say 2 plus 3i, then the conjugate part will be 2 minus 3i. So this is what we are interested in. We use this to multiply the whole function, and then we expand to complete the calculation. From here, the conjugate part of the denominator is giving us a2. There's no need for you to write this, minus ib2. And remember that we only conjugate the denominator, and we use the result to multiply the numerator and the same denominator again. So we have z1, z2 is going to give us a1 plus ib1 multiplying the conjugate part of the denominator, a2 minus ib2. You divide the result by a2 plus ib2 multiplying the same conjugate part, which is a2 minus ib2. So this is it. So once you are able to expand this side and expand this side, then you can complete the calculation. So let's take the first example, and you will get to understand this. So in this example, we have z1 is giving us 3 plus 4i, Z2 is giving us 3 minus 2i. So from here, we conjugate z1 over z2 by picking the denominator and then change the sign of the imaginary part. So when we change this sign, we are getting a positive 1. So we use the result to multiply. And we have z1, z2 giving us 3 plus 4i multiplying the conjugate of this one, giving us 3 plus 2i all over 3 minus 2i multiplying the same thing, 3 plus 2i. So from here, all you need to do is to expand the numerator and the denominator. So we have 3 times 3 giving us 9. 3 times 2 is giving us plus 6i. Then we have 4 times 3 giving us plus 12i. Then 4 times 2 is giving us plus 8i squared. So we have I here. And we divide this result by 3 is giving us 9. 3 times 2 is giving us plus 6i. This time this is giving us minus 6i. And this time this is giving us minus 4i squared. So but I squared is giving us -1. So we can substitute that there. So we are having 9 plus 6i plus 12i. Then when we substitute this here, we are getting minus 8. And we are dividing this by 9 plus 6i minus 6i plus, when we substitute -1 here, plus 4. Now all you need to know is that this and this are the same. One is positive, one is negative. So this will take care of this. And we can add this and this together. And we are having 9 minus 8 is going to give us 1. And then 12 plus 6 is giving us 18i. Dividing, now we add 4 to 9, giving us what? 13. So our z1 out of z2 is going to give us 1 out of 13 plus 18i out of 13. So for division, all you need to know is that you have to apply conjugation. You conjugate the whole equation given to you, and to do that you just pick the denominator, you change the sign of the imaginary part, and that is it. You use it to multiply both the numerator and the denominator, and you are off to go. So this is it. Thank you very much for joining me here. I hope this video has been very helpful. So there are various examples that I will do under this topic, and then in these examples I will talk about both addition and subtraction and division, including multiplication, and then how to use the complex numbers to do other calculations. So stay tuned and stay connected to this channel. Subscribe to this channel if you have not. My name is Daniel, and I hope to see you back here.